This review is on slope fields. The calculator drew it. Here is a solution. A slope field is a bunch of tangent lines, right? Little lines that show the slope, and you follow those slopes to draw a picture. So through one, you can see it rises and rises. So we're going to answer it right on here. So sketch the solution curve through 0, 2. So here's 2, and then if you follow it to the right, if you follow it to the left, you have your answer. Try it for the 0, negative 1. Well, if I follow that to the right, if I follow that to the left, you can see what picture that creates. Here on this side, that was it for that. X plus 1, it's shown here. Draw a solution through 0, 2. And then you think, where's it going to the right? And then as it goes here, what's happening, right? So there's like a turning point, and then you can see it goes up to the left. Can you see this in terms of that? Like it's like a horizontal, diagonal asymptote. From 0, negative 2, again, follow it to the right. I can see that one. And then it rises up here, and again, it's going to follow that asymptote right there. So it rises up, and then it's going to go, and then you can see it there, just following the slopes. All right, that was number 2. Number 3, create your own at x plus, so for each person. So x plus 1 means I only need the columns. So we have x equals 0, x equals 1, x equals 2, x equals 3. This one's negative 1, negative 2, negative 3. And so if I plug in 0, the answer is 1. So I do a slope of 1 all the way down. If I plug in 1, it's 2, so it's a little steeper. 3 is a little steeper. And then plug in 3 plus it's 4 is like really steep. Then if I plug in negative 1, the answer is 0. That's a horizontal slope. And then if I plug in negative 2, I get negative 1. So it's going down. And then if I plug in negative 3, I get negative 2, which is a little steeper, but pointing down. Then I'm going to draw a solution through 1, 0. Let me get it. I'm going to do it in red. So find 1, 0. It's right here. And then follow what's happening to the right, what's happening to the left. And then once it hits this right here, it's a turning point. And you have your graph. We're going to do this too. Now, when it says y, those are the rows. So this is y equals 1, y equals a half, 0, negative a half, and negative 1. So if I plug in 1, the answer is 2. So it goes kind of steep up here, all the way across. If I plug in 1/2, 2 times a half is 1. So it's still going up to the right, but it's more like a 45, a direct diagonal. If I plug in 0, the answer is 0. So these are horizontal right here. If I plug in negative a half, I get negative 1. So it's going down like 45 degrees. And then if I plug in negative 1, I get negative 2, which is a little steeper going down. Then after you draw this, you can press pause. It says draw the solution through 0, negative 1. So you can see what's happening here in terms of the direction of the curve. Now this one's a little more complicated because it takes both the y and the x. So how do I handle that? Well, I look kind of at the diagonal. So I know where it's empty. So when x is 0, it's all empty. So if I go to 1, 1, I know that answers that. And if I go to 2, 2, right? And the same thing here, this whole diagonal, negative 1, negative 1. In terms of the other direction too, if I go negative 1, positive, this will be a positive 1. So I find the diagonal and do positive 1 here. So at least I can get a chance at it. And then we're going to fill in some other ones. Here, when y is 0, now when x is 0, it's empty. But when y is 0, so that 1, 0, these are going to be horizontal. Because 0 divided by 1, 0 divided by 2, 0 divided by 0 divided by... It is going to be empty in the middle because 0 divided by 0, we're not going to put that slope down. So already we've done quite a few slopes. Here, this slope is negative 2 over 1. This slope is negative, here we are, negative 1/2, a little flatter. This one here is negative 1/3, even flatter. This one's negative 3 over 2. That quadrant's done. Here, 2, so this is going to be 1/2. This is going to be 3 over 1. Steeper. Sorry, 1/3, which means it's even flatter. This one's going to be 2 over 3. This one's going to be 2 over 1. These are empty. Here is going to be negative 2 over 1. This one's going to be negative 1/2. This one's going to be negative 1/3. Flatter. And this one's going to be negative 2/3. Last quadrant here. So this is going to be positive 2. This is going to be 1/2. This one's going to be 1/3. And this one's going to be 2/3. Do your best. Kind of see a picture that's happening there. Through 2, negative 1. So 2, negative 1 is right here. So I can see the picture this way, and I can see the picture this way in terms of what the picture would look like. All right, let's solve some diffie q's. So if you like, you can. It says for problem 6 through 8, find first of all the equations through the solution curves you sketched in 3 to 5. So we're going to solve this diffie q. So we're going to separate the variables. So we're going to multiply by dx. They're already separated. This is just y equals x squared over 2 plus x plus c. And then we're going to plug in the point. So let's see if I can do this here. What point did we use for this one? For x plus 1, we used the point 1, 0. So then at this step, you're going to plug in 1 for x and 0 for y. So that ends up with 1/2 and 1. So c is 1.5 or 3 over 2. Oh, you're going to subtract it, right? So if I put it together, it's y equals x squared over 2 plus x minus 3 over 2. So if you type that into your graphing calculator or Desmos, does it match the red curve that's above? You should check, see if that works or not. Number 4. I want to solve this diffie q, so I'm going to separate the variables. So I'm going to divide by y. I'm going to keep 2 there. So it's 2 dx and just divide by y, multiply by dx. When I integrate this, that's a logarithm, and that's 2x plus c. To solve a logarithm, we're going to write this. Oh, and the point that we're given is 0, negative 1. We could do that right now. So if I plug in negative 1, the absolute value of negative 1 is 1, and ln 1 is 0. And then plug in, it's 0. So it's just c equals 0. So we have, this is here. I'll just make that 0 because we now know c is 0. Then to get y by itself, we're going to write it exponentially. So that's 2x plus 0 is just 2x. So it's y equals e to the 2x. In terms of that, and we don't need to have the plus 0 part to that. And it could be positive or negative. So when you get rid of it, so when I look at this one, it's likely the bottom one, which means it's negative. So it's probably y equals negative e to the 2x is what we drew. So if you type that in, because you're given the y coordinate, which is negative. All right. So if you type this into your graphing calculator or Desmos, does it match this red curve? All right, number 8, separate the variables. So I'm going to multiply by dx, and I'm going to divide by y. So this one's going to be divided. So when I integrate, both sides are going to be logarithms. Plus c. And then it says plug in, what point? 2, -1. So that means the x is 2 and the y is -1. So again, when I plug in -1 for y, the absolute value of -1 is 1, and then ln 1 is 0. X is 2, so the absolute value of 2 plus c. So then if I add that to the other side, c is equal to ln 2. So we have ln y equals a negative ln x plus ln 2. To write this exponentially, it's going to be y equals e. Now e and ln cross out, but we'll do that in a second. So it'd be ln x. And instead of multiplying, we'll write the same base, ln 2. And again, the y coordinate is negative. So when I put this together, the e and ln cross out. Oh, there's still a negative there. All right, so this negative belongs then to the exponent inside. So these do cross out, but it's x to the -1. That's right here. And then e and ln cross out, and that's just 2. So if you like, it's y equals 2 over x. And it could be positive or negative because of the absolute value. The y coordinate is negative, so it's negative 2 over x, and that gives you the answer. All right, turn the page. So at the right is a slope field, and it says sketch a solution through 0, 0. So here's 0, 0, and then I'll do it in red again. Oops. So here it is, 0, 0. Follow the curves to the right, follow the curves here to the left, and you get a picture of what it looks like. And then it says find a particular solution to it. So we're going to solve this Diffie Q. So we just have to multiply by dx and then integrate it. So this is y. Now this has a hook. The derivative of negative x is negative, so it needs a negative in front. So if we put it together, it's negative e to the negative x plus c. And then if I plug in 0, 0, don't assume if you plug in 0 the number 0, because e to the 0 is actually 1. So this is -1 plus c, and if you add, I get c is equal to 1. So the equation is negative e to the negative x plus 1. And then it says, without the use of a calculator, determine whether your equation from part B represents the function you graphed. And you can see that it's negative e to the negative x, and it's been shifted up 1. Makes sense to me. All right, part C, we just did, right? Part 10. Part 10, question 10. So multiple choice. The slope field on the right, let me see if I can expand this just a little. Okay, the slope field is here. It's showing what statement is true for the solutions for the different equations. So when x is less than 0, all the solutions are decreasing. So when x is less, I see increasing and decreasing. So I think that one's wrong. All solutions level off near the x-axis. So as you go to the x-axis, as it rises, it does level off on both. So I say yes. When y is greater than 0, that's above, all solutions are increasing. They all are increasing above. Are they all pointing up to the right above? Yes. So the answer then is D, 2 and 3 only. The slope field for this will have horizontal segments when, and so that's when the numerator is equal to 0. And so you can factor out y, and you get x squared plus y squared equals 0. So when y equals 0, that is true. And then what else would be true? This will always be positive. So the only thing that will give it to you is D. Because no matter what numbers you plug in here, when y is any number, negative or positive, this will always be a positive. So the only one that will give you a 0 is when y is equal to 0. So the answer is D. Oh, the other one would be if you get negative x squared, if y equals negative. I don't see that one. No, this is the answer. Okay, number 12. Which of the following could be the graph of the solution of the differential to the right? So if you take a point and you think which one could match it? This is what I see. So this is going down like this. So like these don't have anything that kind of matches it. And if I look here in terms of what's happening here, the one that matches it closest is looking like that, part B. All right, which of the statements is true about the solutions of a diffuse whose slope field shown to the right? So when y at 0 is greater than 0, then the limit of it, the right-hand behavior, is going to 0. And I see where the asymptote is. The right-hand behavior here is going to -2. So this one is wrong. This one's right. And this one's right. I got to read the left part here. So if this y value is between -2 and 0, or if it's less than that, the right end and the left end, the right end behavior is -2 approximately. I get that. So for 13, it's 2 and 3. The horizontal asymptote gives you the right end behavior and left end. Shown at the right is a slope field for which of the following equations? So it could be 1 plus x, this, and so on. So I like picking out a point, maybe in the something where there's a positive and negative in terms of it. So let's say I pick out a point like here, which is like, what is it? So if I pick out -1 and +1, it should be positive, right? So if I put in -1, I get 0. If I put in -1, I get +1. And if I put in -1, +1, I get 0. So the answer has to be, for 14, well, -1, +1. It might be here. Let's try it like up here. -1 and 2. Where's -1 and 2? It's so hard to find a point here in terms of what I'm looking for. So here's a slash. So -1. So let's try -1 and 2. It looks like a positive slope. So we already know this is the one that's going to match in terms of it. And if you plug in a negative number for x, you don't get a negative answer. So this one can't be right in terms of, this is the one that would then match. And you can also see at 0, 0, it's horizontal. You can see these horizontal lines, kind of 1, 1, so on. Oh, a little bit tricky. All right, number 15. Consider that diffie Q on the axis do a slope field for this. And so 0, so right here we have 1, 0, that's here, because 0 for x, 0 times whatever is going to give me the answer 0. Here we have 1, 1, that's going to give me 1/2. Here we have 1, 2, that's going to give me 1. And then this one I have 1, 3, 3/2, so it increases just a little bit more. And then this is going to be the same thing but negative, kind of mirror it. And then the question is so sketch a slope field, right? I did that. Find the particular solution with this initial condition. So I'm going to separate the variables. I'm going to multiply by dx. So I'm going to divide by y. I'm going to keep x over 2 over here with x. And then I'm going to do the integration of that. So it's ln y equals, add 1 to the exponent and divide. You get x squared over 4 plus c. And then we can plug in. So if I plug in 3, I get ln 3. And then for x is 0, so c is equal to ln 3. So I'm going to write this exponentially. I see that the y coordinate is positive, so it'll just be the positive. So this is e to the x squared plus 4 times e to the c. Remember that when they add, you can separate by multiplying with the same base. We can just make that into another constant. So I get, well, we already know what c is. Sorry. So it's ln 3, right? So we can do that. E and ln cross out, so it's just 3. So then I get 3 times e to the x squared over 4. Done. All right, number 16. Consider this diffy q. The slope field for the given differential equation is given here. Sketch the solution curve. So I'm going to get my red pen out here for this through 0, 1. Here it is. And so, like, what's happening to the left and what's happening to the right. So exactly at 0, 1, it's just a diagonal at 0, 1 that goes through there. So if you follow, it's just a diagonal that goes to the right and to the left. If I follow here, this is on a curve that then has this kind of shape to it. It says find the value of b for which y equals 2x is a solution to the diffy q. All right, so I'm going to solve that diffy q. I'm going to separate the variables. So at the point, oh, and sketch it. For 0, 1, here's 0, 1. If I plug in 0 for x and 1 for y, you get b is equal to 1. So it's just y equals 2x plus 1. And that is this line that's right here. Let g be the function that satisfies the given diffy q with the initial condition g at 0 equals 0. Does the graph of g have a local extreme at 0, 0? If so, is the point a maximum or minimum? So we need to take the derivative. We have the derivative. So the derivative is given, dy by dx equals 2y minus 4x. So if I plug in 0, 0, I get the answer 0, right? And so first of all, does the graph have an extreme point at 0, 0? Well, the derivative is equal to 0, so that's one thing. And then you need to take the second derivative to know whether it's a maximum or a minimum. That's the only way to tell. So we're going to take the derivative again of this. So the derivative of 2y is 2y prime minus 4. That's the second derivative. And then we already said y prime at 0, 0 equals 0. So if you plug in that, you get 0, and you get the answer negative 4. So it's concave down there. So that means we have a max at that point because it's concave down, and the first derivative is equal to 0. All right, almost done. Here's your last one. So you have a diffy q. I want you to press pause and try. Can you draw this and then press play? So when x is 0, 0 times anything is 0. When y is 1, it's also 0. So that means right here is 0, right here. When y is 1. And then these are the only ones we need to figure out. So this is 1 and 0. That leaves me with 1 if you solve it. 1 and negative 1. So 1 and negative 1, that's 2, 4, right? So it's 4 times 1, that's 4, so it's super steep. Here, this is going to be negative 1, and the same thing, so this one's going to be super steep, negative 4. Here we have, I'm pretty sure it's going to mirror this one, so negative 1 and 0, yeah. So there's what the graph looks like. And then the question is, here it is, it says, use the slope field for the given differential to explain why a solution could not have the graph shown below. So it goes through 0, 0, but I can see what's going to happen here. And the simple act is that this has an end behavior at 1. So they don't match. So the one above, the end behavior, is going to 1. So the end behavior doesn't match. This end behavior is 1, and this one's going to infinity. All right, that's everything, right? Was there a part C? What do we got here? All right, let's look. There is I think a part C is missing here. I'm going to tell you that you should solve this Diffie Q. So that's what we're going to do right now. So can you solve this Diffie Q? It's good practice. So to solve this Diffie Q, I'm going to divide by y minus 1 squared and multiply by dx. Good practice. Not a logarithm. So we're going to write it calculus friendly, and then we're going to integrate it. So we're going to add 1 to the exponent and divide. And this side's going to be x squared over 2 plus c. And then we're going to plug in the point. So if this is the point it goes through is 0, 0. So if I plug in 0, I get negative 1 c. So c is equal to negative 1. So I have, and this is a fraction, x plus 2, so c is 0, it's just that now. And then how would you solve for y? Well, a couple things here. I would multiply to make the other side negative, so multiply by negative 1, and do the reciprocal. So I have this as the reciprocal, and then add 1, and you have the answer. Perfect. All right, we do have one more. What the hey, there's a lot here. All right, let's get through this good. Match each slope field to the equation that you see. So y equals 1 would mean the answer is always 1 for y. So those are sideways. So which one would do that? This one. So this one would match with, I'm going to call it 18. So 18 matches with this one. So no matter what number you put in, the slope is 1. Here, no matter what number you put in, the slope is 0. Oh, I know it's, sorry, I'm looking differently. These aren't Diffie Qs, these are graphs. So this graph is just a horizontal line, so it matches with D. That's 18. Like this graph, if you graph the solution, would match with H, because it's a line, a horizontal line, y equals x. If I do this, these are going to be 2 pointing up or 2 pointing down in the middle. So it's going to be A is going to match this one. So A matches with 20. If I graph this, it's a cube up to the right and down to the left, so I think it matches with F. X squared, parabola. Which one looks like a parabola? Help me out here. Here, right? This one, C, looks like a parabola. That goes with 22. Sine is a wave that starts in the middle. So that's going to match with E. Cosine starts at the top of the wave up here, right? F. E. No, we already did F. So what's another wave that I do here? dB. So this is going to match with 24, where it starts here. The turning point is on the axis. And then a logarithm goes up to the right. Which one's the logarithm? Oh, right here. Up there. Or if it was this way, it would be on the other side. So this one matches with 25. All right, that wasn't so bad. Oh. What did I do? I put E with E. That's no good. So E goes with 23. I'm being silly. F goes with 21. H goes with H. Geez, Willikers. This is 19. 25. Do I get numbers now for everyone? My goodness. All right, we're there. Now can you match the slope fields? Now it's like looking at the slope fields in terms of it. So if I look at 26, if I plug in, I'm not looking for one that looks like a wave. So for 26, if I do the antiderivative of cosine, it's sine. So which one looks like sine? So sometimes the antiderivative is going to help. The antiderivative here, in terms of what's going to look like for 27, it's going to match here. And I'm looking for 0, 0, right? Like in terms of it. So 27 is going to match with C. 28, where is it undefined? Where at 0? So right here, it's undefined and A. So for 28, which one is the one that's going to match in terms of, these have to be negative here, not positive, because a positive will give me a negative answer. This one's positive. So this one's going to match with 28. D and B, so what's left? So just Y, this is the one that no matter what the Y value is, 30 is going to match with D. So if Y is 1, or if Y is 2, or Y is 3, or -1, -2, -3, so it matches. Hey, that leaves me with 29 goes with B. And that means we're done. Mr. G Math over and out. Great job reviewing slope fields with me. Until next time. Proud of you.